Good evening, class. Today we are going to learn how to solve the equation of x to the power of 6 minus x to the power of 3 equals to 2. So we must subtract 2 from both sides to obtain x to the power of 6 minus x to the power of 3 minus 2 equals to 0. So we must multiply the first and third term to factor the trinomial by the grouping method. So we will obtain negative 2x to the 6. So we need to know what multiplies to be negative 2 and adds to be negative 1 in the middle. In the middle we see minus x to the power of 3, but there is a hidden coefficient of 1 after the minus sign and in front of x to the power of 3. So 1 times negative 2 is negative 2, and 1 plus negative 2 is negative 1. So our middle terms will involve negative 2 and 1. And we factor x to the power of 6 as x to the third times x to the third. So our middle terms will be positive 1x to the third times negative 2x to the third. And we will need to bring down our first and third terms with our new middle terms of x to the power of 6 plus 1x cubed minus 2x cubed minus 2. Now we need to draw a divider line in between two sets of factors. So on the left side of the divider line, they have a GCF in common of x to the power of 3. GCF stands for the greatest common factor. On the right side of the divider line involves a GCF of negative 2. So on the left, when x to the power of 3 is factored out, it will be multiplied by x to the power of 3 plus 1. And on the right side of the divider line, negative 2 is factored out, and then we will be left with x to the power of 3 plus 1. Now, we see an overall GCF that appears on both sides of the divider line in the form of x to the power of 3 plus 1. So that will go on the left, multiplied by x to the power of 3 minus 2, set equal to 0. Then we see that x to the power of 3 plus 1 involves a factor formula dealing with the addition of cubes. X to the power of 3 plus b to the power of 3 is equal to a plus b times a squared minus ba plus b squared. So let's look at x to the power of 3 plus 1. So we take the cube root of x cubed, and we will get a is equal to x, and the cube root of 1, and b will equal to 1. So now we just plug into the formula for the addition of cubes, and we will obtain x plus 1 times x squared minus 1x plus 1 squared. So now we will replace x to the power of 3 plus 1 with x plus 1 times x to the power of 2 minus 1x plus 1 squared, and then bring down the other binomial factor of x to the power of 3 minus 2 equal to 0. So x plus 1 equals 0. You want to subtract 1 from both sides, and we will obtain x equals negative 1. Now we need to do the quadratic formula for x squared minus 1x plus 1 squared. A is equal to 1, b is equal to negative 1, and c is equal to 1. So the quadratic formula states x is equal to negative b plus or minus the square root of b squared minus 4 times ac, all over 2a. So x is equal to negative 1, which represents the minus sign out up front there, times negative 1, or we could say negative of a negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 1, all divided by 2 times 1, which will equal negative, again, times negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 1, all over 2 times 1. So x is going to equal 1 plus or minus the square root of negative 3 divided by 2. When you have an even root with a negative up front, this will yield an imaginary I coming out as 1 plus or minus I square root of 3 divided by 2. And then we solve the other equation involving x to the power 3 minus 2 and set that equal to 0. And you want to add 2 to both sides, and we will obtain x to the power of 3 equals 2. And then you want to take the cube root to both sides, and we will obtain x is equal to the third root of 2. Now, if you need online math help, text 559-744-3169 for services. If you need online math help, please text 559-744-3169 for help. Please donate on the Cash App for my channel with the $ up front, MLBFan. Again, please donate on the Cash App with the $ up front, MLBFan. Again, with the $ up front, MLBFAN. Let's learn math together, everyone. Let's make learning fun. Thank you.